All right, so for today's lesson, we're going to do something we're actually going to learn about something that's not in our curriculum. This was something that you should have learned last year, but you didn't get to because of COVID. So that's why I'm calling this lesson 8.5, because this is kind of an additional lesson that we had to do because you missed so much time last year. And what we're talking about today are radians. I've talked a little bit about radians before, in making sure that our calculators are in degree mode versus radian mode. But today I'm going to talk about exactly what a radian is. And a radian is simply a different way of measuring an angle. So to talk about how where a radian comes from, we need to look at something called the arc length or the distance traveled. Okay, the arc length or the distance traveled is the length of a portion of the circumference of a circle. Okay, so what that means is that the circumference is, of course, the distance around the entire circle. We know that already. The circumference is the distance around the entire circle. The arc length, or the distance traveled, is the distance around a portion of the circle. So you can see in this diagram right here, I have an arc, which is part of a circle, okay? And the arc length, or the distance traveled, would be the actual length of that arc, okay? The figure below represents an angle measure of 1 radian. So 1 radian means that the arc length, so the length of this arc right here, the arc length is the same as 1 radius. So whatever the length of the radius is, the arc length is that same length. If I had an angle that measured 2 radians, that means that the arc length, okay, again, the length of this arc here, would be the same as twice the radius. So an angle of 3 radians would mean that the arc length is the same as the 3 times the radius, so on and so forth. Okay, so in general, a radian is the ratio of the arc length to the radius. So if you want to know how many radians an angle is, you take the arc length and you divide it by the radius. And of course, we know in a unit circle, the radius is 1. So if the circle is a unit circle, then the number of radians is equal to the arc length. So some common angle measurements that you'll see, okay? 2 pi radians corresponds to an angle of 360 degrees. So we know that 360 degrees would mean rotating all the way around the circle 1 full time. So 360 degrees is equivalent to 2 pi radians. Okay, pi radians, so we know that pi is 3.14. Pi radians is equivalent to 180 degrees. So 180 degrees, remember, would be like half a rotation. That'd be going around half the circle. Pi over 2 radians corresponds to a 90-degree angle, so on and so forth. So the question then becomes, how do we convert between radians and degrees? And that's what we're going to learn about today. Okay, so to convert degrees to radians, we're going to multiply the degrees by this fraction, pi over 180. And to go in the reverse direction, so to convert from radians to degrees, we're going to multiply by that. So to show you how it works, I'm going to do a couple of examples here. All right. So let me pull up this first example. So I'm first going to convert, my first example off to the left here is I'm going to convert 140 degrees to radians. So I'm going from degrees to radians. So the lesson notes say if I'm going from degrees to radians, I have to multiply the degrees by pi over 180, and that's exactly what I'm going to do. So I'm going to take the 140 degrees and I'm going to multiply that by pi over 180, and I'm going to simplify. Okay, so I'm going to multiply this and get 140 pi over 1 times 180. Okay, and I can continue to simplify this. All right, I can simplify the 140 and the 180 because those are both even numbers. So if you're ever not sure how to simplify, if you have two even numbers, you can keep dividing by 2 until you get a fully reduced fraction. So if I divided both of these by 2, if I divided everything by 2, I would end up with, let's see, 140 divided by 2 would be 70. So that would be 70 pi, and 180 divided by 2 would be 90. So I would end up at 70 pi over 90. And then I could keep going. Dividing by 2. So this would be, let's see, 35 pi, because 70 divided by 2 is 35, and 90 divided by 2 is 45. Okay, we're still not fully reduced yet. I could divide everything by 5 now, because 35 divided by 5 is 7, and 45 divided by 5 is 9. Now I'm fully reduced. So 140 degrees is equivalent to 7 pi over 9 radians. Okay. So again, I multiplied by pi over 180, and then I simplified. Okay. What if I'm going in the reverse direction? So if I'm going radians to degrees, I'm going to multiply the radians by 180 over pi. So I'm going to take the 4 pi over 3 radians, and I'm going to multiply it by 180 over pi. All right. And I can do some simplification here, again, just like I did before. Okay. I have a pi up top and I have a pi on the bottom. Those can cancel out. Okay. I can simplify the 3 and the 180 because 3 divided by 3 is 1, and 180 divided by 3 is 60. So after all of that, I'm left with 4 times 60 on the top, and on the bottom, I'm left with 1. So 4 times 60 is going to be what, 240? And then over 1, that's going to be 240. So 4 pi over 3 radians is equivalent to 240 degrees. And that is all we do to convert from radians to degrees. So for your cool down today, you'll notice the worksheet that I shared with you has a lot of problems on it. It has 60 problems. You're not going to do 60 problems. What I would like you to do, and it says this in the PowerPoint, is I would like you to choose 6 problems out of the 60 that are on the worksheet. So you're going to do 3 problems that are converting degrees to radians, and you're going to pick any 3 problems that are converting radians to degrees. So you're going to do 3 of one type and 3 of the other type for 6 total. Okay, and that is it for this lesson, what I'm calling lesson 8.5.